Hello, Assalamu alaikum, and welcome back. Today we'll be covering quiz 3 revision, which is about acceleration and kinematic equations. So please have your calculators ready and let's do the questions together. So what's going to happen is I'm going to be answering the questions. Please pause the video, answer the questions yourself, and answer the questions yourselves, and then play the video and look at the steps and the answers. Okay, let's go. Starting with question 1. A motorcycle accelerates from rest at 8.5 meters per second squared. What is its final velocity after 10 seconds? So always a good idea when you're answering these questions. Always a good idea to read the question twice and make sure that you understand it properly. So over here we've got a motorcycle that accelerates from rest. So what does that mean from rest? So that actually means VI, which is the initial velocity, equals 0. So from rest, that means the initial velocity is actually 0, and the acceleration is 8.5 meters per second squared. Now, how do I know that's acceleration? If I'm in doubt about whether this is acceleration or not, just look at the units. Look at the units, meters per second squared. So that's the unit for acceleration. The unit for velocity is meters per second, while the unit for displacement is just meters, and the unit for time is seconds. What is the final velocity? This is what the question wants, the final velocity. Okay, so we don't have that. And then after 10 seconds. So that's the time. Okay, and we do have the time. So this is how I would answer it. I would list what I have. So I've got VI, which is equal to 0. I've got the acceleration, which is equal to 8.5 meters per second squared. Whoops. Oh no, don't start doing that again. I've got time, which is equivalent to 10 seconds, and I want VF. So if only there was some kind of formula that we know that links all of these together, and of course there is a formula that links all of these together, and that is VF equals VI plus AT. So without further ado, all I have to do is insert the numbers into the formula. So that's 8.5 multiplied by 10, which equals 85 meters per second. Please don't forget the units. And if you want to be a bit more pedantic, since we're talking about velocity, velocity has direction, so it's always a good idea to just do positive, which means it's just going forward. Okay, so that's the answer to that one. A skateboarder accelerates from rest. So once again, accelerates from rest, so that's VI at 4.8 meters per second squared, so that's acceleration. What is the skateboarder's final velocity after 5.5 seconds? So it's basically identical to the previous question. We're looking for VF, and we've got time, and so on and so forth. So the answer to this one is very straightforward as well. VI plus AT. Now you'll notice that I always start by writing the formula, because remember the four steps, the four parts of the answer. We've got formula, workout, answer, units. Formula, workout, answer, units. So it's always a good idea to do that, just for checking purposes as well. It's much easier to see your work when you're doing it, and also for the marker to see what you're doing. So what's VI? Once again, that's 0. Acceleration is 4.8. And the time is 5.5 seconds. And the answer is going to be approximately 25 or so. Let's see, 4.8 times 5.5. That is 20, oops, where's my marker? 26.4 meters per second. And once again, I'm just going to add the positive. So that's the answer there. Let's go to the next one. A climber accidentally drops his backpack from a height of 60 meters. So this is a slightly different question now. Much more interesting indeed. How long does it take for the backpack to reach the ground? Okay, so what do we have? Remember, we need about 3 variables. So a climber accidentally dropped their backpack from a height of 60 meters. So we've got VI, which is 0, because that is, okay, so here is the 60 meters, like a cliff. And then we've got the dropped backpack, and I'm going to try and attempt to draw a backpack. Here we go. There's the backpack. Lovely backpack. We know the height is about 60 meters. There we go, 60 meters. We know the VI is approximately 0. So what do we have here? We've got the displacement, which is 60 meters. But we need one more variable. I wonder if we can get one more variable. What about the acceleration? Do we have that? Of course we do. It's g. Remember, it's acceleration towards gravity. So that's going to be 9.81 meters per second squared. And now we've got everything we need. What is it asking for? How long does it take for the backpack to reach the ground? So we're looking for time. Can we work out the time? Indeed, we can. Okay, so what we can do is we can say initially we need to work out the time. So one way we can work out the time is by looking at the acceleration, and the acceleration equals 9.81. So let's have a look. We've got an equation here. Delta D is equal to VIT plus half AT squared. Remember, A in this case is the same as G, which is acceleration towards gravity. So we can rewrite this as delta D is equivalent to VIT plus half GT squared. Now, let's have a look. If we look at this, what's VI? VI is equivalent to 0. So that whole thing can be cancelled out, because remember, 0 times anything is 0. So we can just cancel all of that. So delta D is equivalent to half GT squared. And so we can put in some numbers. 60 is equivalent to half multiplied by 9.81 multiplied by t squared. And you can either use shift solve at this stage, or you can do some simple rearrangement. So you can say 60 divided by half of times 9.81 is equivalent to t squared. And so therefore, those three circles, they mean therefore, t is equivalent to the square root of all of that. 60 divided by half times 9.81, which equals, well, 60 divided by 0.5 times 9.81. And then I want the square root of that. So that's approximately 3.49 seconds. Oh no, 3.5 seconds. Okay, I hope that wasn't too hard. Just work through the steps basically. Let's have a look at this one here. If a train accelerates at 2.3 meters per second squared for 6 seconds, so we've got acceleration, we've got time, and starting from, we've got VI, 1.5 meters per second. What is the final velocity? We're looking for VF. Very good, we've got everything else. So VF is equivalent to VI plus AT. Excuse me for a second. Don't need that. So VF is equivalent to 1.5 plus 2.3 times 6, which is approximately 15. 1.5 plus 2.3 times 6. Yep. So 15.3 meters per second, and because we're talking about velocity, always a good idea to say plus. So there you go. A plane accelerates from rest. So remember, every time we see this, it means 0. So VI is equal to 0 to 50 meters per second squared. So this is VF now. 50 meters per second in 8 seconds. 8 seconds. What is the acceleration? Okay, so this time I'm going to use a slightly different formula. Well, a slightly different form of the same formula. So that's Vf minus Vi all over T. And so let me switch to green. Acceleration is equivalent to 50 minus 0 all over 8, which equals to 6.25 meters per second squared. And if you want to, once again, you can add the plus, because acceleration is also a vector, just like velocity, just like displacement, just like force, just like momentum. Okay, a tennis ball is thrown straight up. Okay, this is an interesting one. So we've got a tennis ball that is thrown straight up. What is the acceleration at the top of the path? Remember, when things are thrown straight up, it doesn't matter whether they're thrown straight up or straight down. The acceleration here, which is g, is equivalent to the acceleration here. It's equivalent to the acceleration here. It's all g. Okay, that's g. That's g. G is the pull from gravity. It doesn't change. It's always going to be 9.81. Okay, so the acceleration at the top of the path is 9.81 meters per second squared. It's always the same. The velocity on top of the path, though, is going to be 0. So even though the acceleration is going to be this, the velocity is going to be 0. The reason why the velocity is 0, because when you throw something up in the air, when it goes to the top of the path, it's going to be, for a moment, it's going to be completely stopped or stationary, and it's not going to be moving. And that's why the velocity is 0. However, the acceleration from gravity is always there. You can't switch it off. So the gravity is always working. So that's always going to be 9.81. So don't be tricked by this question. If it's asking for the acceleration, it's always there. So it's always going to be 9.81. However, the velocity changes. So the velocity in the initial phase is going to be different to the top of the path. And then as it's coming back down, the velocity changes direction. So don't be tricked by that question, okay? Right, next. A person drops a stone from a height of 180 meters. So here we go. So this height here is 180 meters. 180 meters. And the person drops a stone. How long will it take for the stone to hit the ground? So this is like the question we answered before. What do we have? We've got Vi, which is equivalent to 0, and this is important because that's going to cancel that first part of the equation and it'll just make it a little bit easier to work out. So delta D, which is displacement, is equivalent to VIT plus half GT squared, or half AT squared if you prefer. But remember, Vi is equal to 0. So I can cancel all of this. What else do I have? I've got delta D, which is equivalent to 180. I've got G, which is 9.81. And so let's have a look. So delta D, which is 180, is equal to half times 9.81 times T squared. Okay. And so in order to get the T, I'm just going to do some mathematical gymnastics. And that's equivalent to the square root of 180 over half times 9.81, which is equal to, unfortunately, I don't think I can do that one in my head, or can I? 180 divided by 5. Just back into the square root of 30. No, square root of 30. It's approximately 5. Let's have a look. Divided by 0.5 times 9.81, and oh, it's 6. Not too bad. So that's about 6.1 seconds. Okay, let's move on. A cyclist travels 90 kilometers in 3 hours. What is the average speed for the cyclist? So remember, average speed is, we can actually write it like this. Velocity average, which just means the average velocity, is equivalent to total distance divided by total time, or displacement divided by time. Since I'm looking for speed, I better just stick to it. So speed equals total distance divided by total time. So in this case, I've got 90 kilometers divided by 3 hours, and that's going to equal 30 kilometers per hour. Now, if we were looking for the average speed in meters per second, I'd have to convert this, but we're not looking for that. But if I did want to convert this, I can do that pretty easily. I can just go 30 kilometers per hour to meters per second. And the way I do that is, remember, 30 kilometers is 30,000 meters per hour. And then in order to get the seconds, all I have to do is divide by 60 to get how many meters per minute, and then divide by 60 again to get how many meters per second. So that's going to be 30,000 divided by 60 again, which is going to be 8.3 recurring meters per second. Okay, moving on. A rocket accelerates from rest at 12.5 meters per second squared. What is the final velocity after 9 seconds? Interesting question. Now, don't really like this question. The reason I don't like this question is it doesn't say if the rocket is going upwards or if it's going sideways. So I'm just going to assume it's going sideways because it just makes it slightly easier to work out. So a rocket is, let's have a look. Here's the rocket, and I've got to put some fins on it, and there we go. And that's accelerating that way that's the acceleration, remember, at 12.5 meters per second squared. The initial velocity is 0. And what is the final velocity after 9 seconds? I've got time, which is equal to 9 seconds. Well, that's pretty easy as well. So I'm going to switch to orange. VF is equivalent to VI plus AT. Now, how do I know which formula to use? Somebody might be asking. Well, you really have to look at the variables that you've got. So what do I have here? I've got VI, I've got the acceleration, I've got, that's what I'm looking for, final velocity. I don't have that, but I have this, and this. And what I need to do is I need to find a formula that encapsulates all of these. Okay, so I've got VI, A, VF, and T, and I'm looking for VF. Which formula is that? Well, it's the one that links all of these together, which is VF equals VI plus AT. And so that's 0 plus 12.5 multiplied by 9. And so 12.5 multiplied by 9, I should be able to do that. 112.5 meters per second. Okay, let's move on. I hope that wasn't too challenging. A bird drops a twig from a height of 30 meters. How much time does it take for the twig to hit the ground? Okay, so once again, 30 meters. And we've got a bird. Oh, so it's not a cliff this time, it's a bird. I'm drawing a plane instead for some reason. I'm really terrible at drawing using this. Well, anyway, so here's the twig. And we've got 30 meters, well, nearly a height of 30 meters. So what do we have? We've got delta D, which is 30 meters. We've got VI, which is 0, and that's important, remember, because that cancels that first part of the equation, which we don't need. VIT plus half AT squared. What else do we have? G, of course, which is 9.81. And let's work it out. So 30 equals, we can cancel this all together because 0 times anything is 0. So this becomes, oh, I forgot the half. Don't forget the half. Half GT t squared. So we can just do t squared is equivalent to 30 divided by half g, which is half times 9.81. We don't want t squared, we want t. So t is equivalent to the square root of all of that. So 30 divided by 0.5 times 9.81. And don't forget the square root. So 2. Therefore, time is equivalent to 2.47 seconds. Okay, let's move on. Let's switch to, how about we switch to red? A runner accelerates from 3 meters per second, so that's VI, to 8 meters per second in 4 seconds. What is the acceleration? Easy peasy lemon squeezy. VI plus AT. Oh, okay. Oh, actually, I can use a different form of this, which is acceleration equals Vf minus Vi over t. So acceleration is equivalent to 8 minus 3 all over 4, which is 1.25 meters per second squared. Okay. A car accelerates at 3 meters per second squared, so that's the acceleration, for 5 seconds, which is the time, starting from 6 meters per second. Starting from, so that's Vi. What is the final velocity? We are looking for Vf. So that's going to be Vf is equivalent to Vi plus At. We've got Vi, which is 6. We've got A, which is 3. And we've got T, which is 5. So that's going to be 21 meters per second. Let's move on. A diver jumps from 20-meter high cliff. How long does it take to hit the water? So once again, Vi is equivalent to 0. So this helps a lot, because delta D is equivalent to VIT plus half AT squared. And of course, A is G, and you have to remember that G is equivalent to 9.81, always, meters per second squared. So I can get rid of this, and I can just do 20 is equivalent to half times 9.81 times t squared. Therefore, t is equal to square root of 20 divided by half times 9.81, which is equal to 20 divided by 5 is 4, and this is, it's pretty close to 2. 20 divided by 0.5 times 9.81, and square root of, yeah, so it's 2.02. I'm just going to say 2. 2 seconds, and that's fine. Next, nearly 75% of the way there. A boat accelerates from 2 meters per second Vi to 10 meters per second, which is Vf, in 6 seconds, which is time. What is the acceleration? Acceleration is equivalent to Vf minus Vi all over t. So 10 minus 6, oh no, not 6, 10 minus 2 all over 6. 8 over 6 is going to be 1 and 3, 3 recurring. Meters per second squared. I think we need to switch to a different color. How about black for a change? Let's have a look. A truck accelerates from rest, so that's Vi equals 0. Acceleration. What is the final velocity? We're looking for final velocity, or Vf. We don't know that. After 7 seconds. So we've got time, we've got acceleration, we've got VI, we're looking for VF. VF is equal to VI plus AT. So 0 plus 5.2 times 7, which is 35 and 36.4. 36.4 meters per second. Next, a ball is thrown upwards with an initial velocity of 15 meters per second. How long will it take to reach its highest point? Now, this is a good question. Now, here we've got a ball that is thrown upwards. Oops. So the ball is thrown upwards, and then obviously it comes down. We don't care about the coming down part though. We want to know how long it takes the ball to get from this point to this point. So what do we know? We know that the initial velocity up, VI, is equal to 15. Now, I'm going to do something slightly different now. Since the velocity is going up while the acceleration is going down, I'm going to start putting signs on it. Now, when things were falling, I didn't bother with signs because the velocity was in the same direction as the acceleration. So the acceleration is going down, so negative 9.81, but since velocity is also negative, I just ignored both signs, and that worked fine. However, now, the velocity is going up, so I'm going to have to put positive 15, and then the acceleration that's acting on the ball is always going to be down. So G is negative 9.81 meters per second. This time, it matters to put the signs. So this is a situation where it's important to put the signs because they are opposite to each other. So we've got G is equivalent to 9.81. We've got the initial velocity. What are they asking for? They want to know how long it takes to get to the highest point. Well, we still need one more thing. We need VF. How do we get VF? Well, remember what I said. Acceleration is always going to be 9.81. We can't change that. You can't switch it off. But the VF changes. The velocity of the ball is going to change as it goes up. Initially, it's traveling at 15 meters per second, but right at the top for a moment, it's going to be 0. So we know that. We know that VF at the highest point is going to be 0. And so now we can work it out because what are they asking for? How long? They're looking for the time. So using the information I have, I can work out the time. Acceleration is equivalent to VF minus VI all over t. So if I'm looking for t, I can just do some mathematical gymnastics and I can say that t is equivalent to VF minus VI all over a. Oops. Just by multiplying that side by t and then dividing this side by a, I can get that. And so it's going to be 0 minus 15 all over negative 9.81, and that's going to be approximately 1.5 seconds. So negative 15 divided by, sorry, let me just do that. Negative 15 divided by negative 9.81, and that is 1.53 seconds. Okay, and of course you don't need to put a sign on time because time is a scalar, so no plus or minus. Moving on, a car accelerates from 5 meters per second to 25 meters per second. So that's the initial velocity VI, and that's VF in 8 seconds time. What is the acceleration? Okay, so hopefully you find these quite easy now. Acceleration is equal to VF minus VI all over t, which is going to be 25 minus 5 all over 8. So that's 20 divided by 8, which is 2.5 meters per second squared. Okay, 3 questions to go. A skydiver jumps from an airplane at a height of 500 meters. How long does it take to reach the ground? Okay, so once again, we've got the displacement. 500 meters down. 500 meters, and that is delta D. What else do we have? We've got VI, which is 0, and we've got the acceleration, which is G, which is 9.81 meters per second squared. Now, some of you might be tempted to think that VF simply equals 0, but it doesn't. VF doesn't equal 0. Whilst it's true, the skydiver, once they hit the ground, if they hit the ground, of course their velocity is going to turn to 0. This is due to an external force, i.e. the ground. So we don't count that. We count the final velocity as the velocity just before hitting the ground, okay, due to acceleration. So we don't know what final velocity is, so we can't really use that. So what we can use are these things here. So once again, we'll do delta D is equivalent to VIT, which cancels out because VI equals 0, plus half GT squared, or half AT squared. And so 500 is equivalent to half times 9.81 times T squared. And therefore T is equivalent to the square root of 500 all over half times 9.81, which is equivalent to 500 divided by 0.5 times 9.81 square root, so 10. Did I do that right? I think so. Yeah, it makes sense, I guess. 10.1, no, sorry, not meters per second, 10.1 seconds. Did I do the units correctly before? I think so. Okay, we're good. A jet accelerates from 50 meters per second to VI equals 50 to 150 meters per second, and that is VF. And time is 10 seconds. What is acceleration? Okay. Last question. A stone is dropped from a bridge, which is 100 meters above a river. How long does it take to hit the water? We should be experts at doing these now. Delta D is equivalent to VIT plus half AT squared. That doesn't exist because it's dropped, which means VI equals 0. And so 100 is equal to half times 9.81 times T squared. And so I'm going to move all of these on that side. So 100 divided by half times 9.81 is equivalent to T squared. And then if I do a square root, I can get rid of the squared. And so therefore T is equivalent to 100 divided by approximately 5, so that's 20, and the square root of 20 is approximately not 4 and not 5, so it's about 4.5 seconds. Okay, so I hope you didn't find that too hard. Yeah, just make sure you read the question once or twice or 3 times even. Make sure you understand what the question's asking of you, and write the variables that you've got, and then look at the formula, which formula contains what you need, and good luck. That's basically all you need. Best of luck. Bye bye.